Hello and welcome to our presentation. We are group number 16. My name is Adrian Gonzalez. My partners are Ryan Manalo and Ryan Diana. We will be talking about brake design for applications other than cars. All right. One of the applications that we are talking about today is air brakes as they are applied to trains. All right. Basic concept of the air brake is that it uses the compressed air to actuate the pistons that control the mechanism that clamps the brakes down onto the wheels or releases the brake from the wheels. All right, these brakes, once they clamp down, obviously cause friction against the wheels, converting the kinetic energy into heat and therefore stopping the train. The original system used one compressor for the entire train. All right, and so each car had to be connected one to the other, and therefore there was a lot of potential for air leakage. So this was an inherent design flaw in the original concept. The original concept was designed by George Westinghouse, and it is actually still in use today, not in its original form, but the concept of the air brake. So it's actually a phenomenal design. Some of the improvements that have allowed them to continue to use this system is applying tanks at each car as opposed to one tank for the entire train. That way, if there is air loss or if there's air leakage at one car, it does not affect the braking capacity of the rest of the cars. Another improvement is the triple valve. This triple valve is a dual purpose name. It's a triple valve because it has three separate valves inside, and also because it serves three purposes. All right. One of the purposes is to allow air to fill into the storage tank. All right. The second item is to pressurize the system. All right, which releases the brakes. And the third option is to release the air, which allows the brakes to be applied. That's the way the system works. When the air is released, it actually applies the brakes. This is what allows the system to be designed to be called a fail-safe system. All right, it's fail-safe because if there is a leak and the air releases, the brakes will actually come on, as opposed to the other way around, which will allow for trains to be a runaway train and have accidents. All right, some of the further improvements, they've started electro-pneumatic brakes, where instead of having to open and close the air valves or change the setting on the valve to control the brakes at each car the way they used to do. They used to have somebody at each car or somebody in charge of 2 or 3 cars, and when they would sound the whistle a certain way, then that guy had to run and actuate the brakes one way or the other for several cars. Now, from one location, they can send an electrical current through the train system and actuate the motorized valves. Now, the problem with that is that it is sequential. So as the signal goes along the train, depending on the length of the train, the cars start braking, sequentially as opposed to all together. Another improvement is anti-lock brakes. Used to be, obviously, the brakes would just clamp down and they'd stick, and the wheels would slide, so it would increase their stopping distances. Now the anti-lock brakes allows the system to modulate the brakes, reducing the stopping speed, the stopping distance, and improving the safety. One of the most recent is electronic control. So now it's all computerized. You can actually not only send the signal electronically through a local area network throughout the train, but you can also monitor through a series of sensors, so you can see that every tank is at what pressure it's at, that it's within its operating limits and all that. Some of the disadvantages of the air brake system are depleted storage tanks. If you get into a situation where the brakes, where you're applying the brakes and stopping the brakes, and the storage tanks start to deplete as you fill the line and then release the air, and fill the line and release the air. So you could end up depleting the system and losing your ability to apply the brakes. And then obviously it takes time to recharge the tanks. All right, so there are some disadvantages to the air brake system, but it is still the best system right now for trains, and still based on George Westinghouse's original design. All right, now let me pass it to my partner Ryan, who will be discussing conveyors.
Alright, just to give you a brief background about conveyors, how they work and how they supply a system or whatever mechanism they load on it. Conveyor systems are used widespread in any applications, industries, manufacturing, or even in the automotive industry on it. Safely, because conveyors are more safer than a forklift, just to bring material from one point to another on it. And basically they can be installed anywhere, airports, manufacturing company, fabrication or anything like that. As I said, it can move any loads and all shapes and sizes and everything like that. And there's a variety of options for running conveying system, mechanical, fully automated, or everything that's run by pneumatic systems. Actually, you could use that too on it. Basic question on it, why put brakes on a conveyor? One of the reasons is right here. One good example is the downhill conveyors for speed control. This is a good example right here, where in the mining industry they use the conveyors to load these ores to a loading facility on it. I mean, if you don't have any brakes or anything like that, they would just start strolling around that conveyor without anything stopping them. Another reason you need to put brakes in conveyors is to stop the conveyor in a specified time. Just for this example, it's in a manufacturing facility on it. If you don't have any brakes, how do you supposed to stop one process, a part of the process, like packaging stuff and putting it in a box on it, if they don't stop at a specific time in the operation? And basically to prevent buildup of materials. This picture is taken from a recycling facility in Africa, which you could tell that they lack in technology and everything like that. As the trash is being loaded up on this conveyor, they just keep on piling on a big mountain-like form like that on it, which could be prevented if they have brakes on the conveyor on it. And lastly, for safety considerations, this is like a good animation of how people tend to fix things on their own, and they end up hurting themselves or sometimes fatality on it. This is a popularly used brakes on conveyors types that they usually use, thruster and thruster operated brakes. This doesn't need no external components, meaning that they don't need external motors or any device to help them out to put brakes on. And it always gives a constant thrust of operating the brakes and smooth and jerk-free operations, and basically it's compact and maintenance-free on it. This is usually they use in industries right now because it's compact and maintenance-free, and parts are usually always available on it. And another example is the alternating current electromagnetic brakes. This usually uses for emergency brakes, usually when they have to stop an operation on it, on a conveyor. And also very good on vertical load applications if they have to suspend something, an object or an item along the conveyor on it. And next one is the direct current electromagnetic brakes, used when a load must be stopped rapidly on it. It doesn't require to be an emergency situation. If you want to stop an operation, this is one being used right now. Being simple in design, they always try to implement this, and also with efficient transmission and braking action, they usually implement this because of the quick maintenance, and as usual, parts are always available. Alright, next is for my groupmate Ryan to discuss roller coaster braking systems.
All right, when everyone thinks roller coaster, they think of fun-filled an adventure, but no one actually thinks of the braking, which is one of the most crucial parts of it. There are two methods used in braking on roller coasters. There's trim braking and block braking. There's also 3 different types of braking. There's skid brakes, fin, and magnetic. The braking methods, the first one is trim brakes. It's the most used one. Trim braking is usually found throughout the tracks in random spots, usually at the beginning and the end. It's used to slow down the car and control the speed, not necessarily bring it to a complete stop. They're usually implemented in design part of designing the coasters, or usually later during testing they find out that there's higher than calculated speeds, so they want to reduce the speeds of the car. The next braking method is block braking. Block braking is used to bring a car to a complete stop. It's only used on tracks where there's more than one car running simultaneously. In the event that one of the cars stops, it's used to avoid a collision. Block brakes are usually implemented on parts of the track where there's a downhill slope coming after, because once a cart stops, you have to resume it somehow. So instead of having more components, they usually do it in areas where it's easier to restart the car after. The types of brakes, there's skid brakes. This is a picture of a skid brake. It's the oldest form of braking on roller coasters. It's literally two metal panels, usually coated in ceramic, that raise and create friction against the bottom of the cart to slow it down. It's not really used in current applications anymore. The other type is fin brakes. It's the most common form of braking. Essentially, it's like a disc brake on a car, where there's a fin where it's usually mounted like a rectangular box underneath the cart, and the braking system itself is on the track. So it's almost like as if the fin was the rotor, and it passes through this braking caliper on the track, and the caliper squeezes the cart to bring it to a stop or slow it down. The third one it's growing in popularity because it's very smooth, very quiet. It's silent actually. Is magnetic braking. As it's pretty much the same design as a fin, but as it passes over the magnetic surface, which is right here, it creates resistance forces in the opposite direction. So it's not as jerky as fin braking. It's a smoother decrease in speed, but the disadvantage is that it can never bring a cart to a complete stop. So magnetic braking is usually used in junction with fin braking, which you can see right here. So the fin braking is used to bring it to a complete stop. And that wraps our presentation. Thank you.